Welcome, dear students, to the lecture. Now, today's topic is power series. In the previous lecture, I have explained you what is meant by the infinite series, and a type of infinite series is the geometric series, and what is the limit of the geometric series when the series will be convergent. All that I have explained you in the last class, and now in present video I am going to explain you about the power series. What is meant by the power series means it's another type of a series. It is another type of a series which is involving a variable. It's a type of a series. It's a type of a series, infinite series, which consists of the variable. Which consists the variable. Suppose now the power series is consisting of in fact we can say that it consists of the polynomial of the variable. It consists the polynomial of the variable. Polynomials. That means it can be expressed in this way. That is summation n is equal to 0 to infinity Cn times of x to the power of n, where x is a variable and is powered, and it is powered. The variable is powered, and so we call it as a power series. And this power series is centered at the origin, you can say. Actually, power series is centered at the point x is equal to 0. Or you can even say that it is summation n is equal to 0 to infinity Cn into x minus a the whole power n. Again, now the power series is powered with the power n, and it is centered at x is equal to a. It is centered at x is equal to a, we can say that. So now it is again, this power series is again nothing but the geometric series, you can say. Now let us expand this series now. When I expand this series, when n is 0, it is c0. When n is 1, it is c1 into x power 1. When n is 2, it is c2 x square. When n is 3, it is c3x cube, and so on. So this is nothing but a polynomial, right? So it consists of the polynomial. So this is the series where now as I explained you in the previous lecture that it's a geometric series, right? The power series is the geometric series. Now what is the common ratio? The common ratio is given by r is equal to, what is the second term is x, and if you are getting the first term, when you find out the multiplication of this term, it is multiplied by x, right? So you get whenever you are multiplying by x, you are getting the second term. When you multiply with x again, you are getting the third term, some constant time of the third term. So we say that it is the common ratio is given by x, you can say. Okay, so the geometric series is r is equal to c1x by c0 if I write. Now this is c1 by c0 times of x. Now this is nothing but, now this operation, this particular number is multiplied by the next number, you are getting the second term, like that. For example, instead of writing some constants, if I write suppose x power n, where n is from 0 to infinity. Now then you can understand very clearly, x power 0 is 1, x power 1 plus x square plus x cube, and so on. So what is the common ratio here? It is a geometric series. The second term by first term, that is x by 1, which is equal to x. So if you multiply by x to the first term, you will get the second term. Multiplying by x to the second term, you are getting the third term. Like that it is. So this is called as the geometric series with the common ratio x. Now, when the series is convergent, because it is a geometric series, in the previous lecture I have already explained you that limit n tends to infinity, the nth partial sum of the series That means this x to the power of n as n is going to infinity, where that is given by is converging with the term a over 1 minus r. What is a? A is the first term and r is the common ratio 1 over 1 minus x. Now this series is convergent. When it is convergent, if this value, the ratio mod x is less than 1, common ratio is less than 1. If mod x, the common ratio, is greater than or equal to 1, then it is divergent. So you can say that the series is, I can write like this. Let me do like this. So it is equal to this, and the series summation n equal to 0 to infinity x to the power of n converges if mod x is less than 1, and the series diverges if mod x is greater than or equal to 1. So try to memorize this, that the geometric series, the power series, which is the geometric series, converges if the common ratio is less than 1 and is divergent if the common ratio is greater than or equal to 1. So this is about the power series explanation. As I told you that when you take 1 by 3, and in this lecture I have explained you that the converges to this point when it is convergent if 1 by 3 is less than 1. So since r is the ratio which is greater than or equal to 1, suppose if the series is divergent. This I explained you in the previous lecture. Just go through that lecture, you will understand. And now let us go to the next series. Whenever the series is convergent, you can say that the common ratio given by mod x is less than 1. So let us now